Right, so now we are going to discuss the concept remainder theorem. Right, very important. Already we have learned what is remainder, right? What is remainder? Suppose if I take 40 is divisible by 8, then what happens? The remainder 0. If remainder is 0, what does that mean? The dividend is perfectly divided, right? That means the dividend is perfectly divided or completely divided, right? Then only you will get r equal to 0. Suppose 42 divided by 8. What is the thing? You got r equal to 2, right? So the remainder can be 0 or any other number. That means remainder should be always a whole number, right? So remainder should be non-negative. So remainder is whole number. That means what is that? Remainder should be non-negative. What does that mean? Remainder should not be negative at all, right? Remainder is always, you should have a positive value, right? You need to have a positive value always for remainder, right? Clear? Right. Now I will take one example, right? The product of 17 and 23, what will be the remainder if I divided with the 12, right? What will be the remainder if I divide with the 12? What is the product of the 17 into 23? Right? 391. Right? 391 by 12. Right? What will be the remainder? 12 threes, 36, 31, 12 fours, 12 twos, 24, 7. So remainder is 7. Right? This is a small number, so easy. But still, for finding the remainder, there is one methodology which is very easy to apply to find the remainder. Right? Now, here you need to take individual remainders. Right? So, what will be the remainder when you divided 17? What will be the remainder when you divided with 23? By 12. What will be the remainder when you divide the 23 by 12? Then what will be the remainder when you divide the 17 with 12? Right? You can apply the remainder logic individually. Then this will be the easy calculation without putting a pen. Right? What is the remainder here? 5 into. What is the remainder here? 11, right? So this is 55. So again you need to divide with 12. 55 by 12, right? 12 fours 48. So 55 minus 48, 7. So the remainder is 7, right? Understood how we need to do, right? This should be like this, right? So what we need to apply here? You need to apply the remainder rule individually instead of grouping. Shall we do one more example? Right. Now, what is the remainder for this? The example is, find the remainder for 11 into 12 into 13 into 14 into 5. Instead of multiplying and dividing with 5, you make individually, right? So what you get here, remainder 1, here 2, and here 3, and here 4, right? So divide with 5. Now this become very small. 2 3s are 6. 6 into 4, 24, right? 24 by 5. So remainder is 4. So remainder is 4. You can multiply. You can multiply and do it. You will get the same remainder. Understood? Shall we do one more example? Right. Now see one more example. Find the remainder when 73 plus 75 plus 78 is divided by 34. Right? What is saying? 73 plus 75 plus 78 by 34. right? We will do in normal method, right? What the value you are getting by adding these numbers, you are getting the number 226 by 34, right? So 226 divided by 34, so 34 6 are 204, so the remainder is 22, right? By applying the remainder theorem, we will see the answer, right? How to apply the remainder theorem? You need to apply remainder theorem for every individual, right? What is the remainder when you get divided with 34? What remainder you will get when 73 is divided by 34? So 5, right? 73 minus 68, 5, plus here 75 minus 68, 7, 2 times, right? 10 by 34, so 22 by 34, so the remainder is, see, the numerator is less than denominator, so definitely the numerator will be the remainder, right? So remainder is 22, right? One more example shall we do? Right. Now see another sum on the additions, right? What he told, find the remainder when 14 plus 15 was divided by 8, right? 29 by 8, right? For easy understanding, I am giving the small numbers, okay? It might be seems to be easy, but by applying the remainder theorem, it will be more easy, right? 8 3s are 24, so the remainder we need to get is 5, right? Now by applying the remainder theorem, right? By applying the remainder theorem, we need to find the remainder, right? Now we need to see individual remainders. What is the remainder when 14 is divided by 8? 8 1 8, so you get 6 plus 7 by 8, so 13 by 8. So what the number you get remainder? 5, right? Clear? Concept is clear? Good. Now see the question. Another example. Find the last two digits of the expression 22 into 31 into 44 into 27 into 37 into 43. They are not asking the remainder when divided by some number. They are not asking that one. Okay, they are asking to find the last two digits of the expression, right? If they ask the unit digits, simply we will multiply the unit digit, right? But they are asking last two digits. Before going to this problem, I will explain one example, right? 12 into 15. What is the value of the 12 into 15? 180. What is the last two digits for this number? 80. This is the small number, that is the reason we know, right? But to know these last two digits, I need to divide with 100. Then I can know last two digits of that number. See, if I divide with 100, what happens? 100 ones 100. So what is the remainder? 80. So in other way, how can I find that remainder? By dividing with the 100, right? By dividing with the 100, I can find the remainder, right? The same thing here, if you need to find the last two digits by applying the remaining theorem, how you can find the remainder? By dividing this number with the last two digits, with 100, right? You can find the last two digits by dividing the 100, right? Understood? Clear? Good. Now how you need to do? Right, here 4 11s, 4 25s, right? We divided with 4. Now we will take the small numbers, right? So what the remainder you get here? I will put 22 this way because the less. Then here I will get 6. I will put 11. Here 2. Then here 12. Then here 18. Right? This I can written as 132 into 22 into 216 by 25. Right? Then here I will get 7 into 22 into 16 by 25. So the remainder will be 154 into 16 by 25. Then here remainder 4 into 16 by 25. 64 by 25. Then the remainder will be 14. Right? The remainder will be 14. But what we have, but this is not the actual answer, because we have, when we get the last two digits, when we divide with 100, but here we divided with the 25. So again you need to multiply with 4. So the last two digits is 56. Right? You can check with your calculator. Right? This is the way we need to find the last two digits of the expression. Right? Clear? Now see the another example. Find the remainder when 43 power of 197 is divisible by 7. Find the remainder when 43 power of 197 is divided by 7. What is saying that 43 197 by 7. What will be the remainder? Right? Right. What is the meaning of this? 43 into 43 into 43 into so on into 43 197 times. Right? It should be divided by 7. Right? This is the thing. According to the remainder theorem, what we can do here? Individually, check with individually. 43 by 7. What will be the remainder? 1. So everything it should be 1. So the remainder is 1 for 197 times. Right or wrong? So divided by 7. So remainder will be 1. Right? So what is the thing here? 43 by 7. The remainder is 1. 43 square by 7. The same thing. 1 into 1 square by 7. 1. See, when you have the divider, okay, when you have divisor as a prime number, okay, when you have divisor as prime number, okay, suppose 43 197 by 7. What you get the remainder? 1. Right? For 43 1. So first you need to check what is the remainder for 43 by 7. 1. So the same rule can be applied when you divide 1 power of 197 by 7. The remainder will be same. Right? When divisor is a prime number. Okay, you can make into small and you can do the problem. Right? To clear this concept, one more problem we will discuss. Right? See the another example. Find the remainder when 59 power of 28 is divided by 7. What he asked to do? Find the remainder 59 power of 28. Right? This is the question. Right? See, divisor is the prime number. When divisor is the prime number, the first step you need to do is 59 by 7. What is the remainder for 59 by 7? 7 8s are 56. Right? 3 will be the remainder. Right? 3 will be the remainder. Now you can apply 3 power of 28 by 7. Right? This way you can reduce the number. Right? So the same remainder will be applicable for this number also. Whatever you get the remainder for this, the same thing will be for this number. That is the advantage of the prime number being as a divisor. Right? Right. Now 3 power of 28 by 7. How we need to do? Right. First, 3 power of 1 by 7. What is the remainder for this? 3. So 3 square by 7. Right? 9 by 7. So 2. 3 cube by 7. Right? See, you no need to do always 3 cube 27 by 7. No need to divide. Okay. What is the 3 square by 7? 2. What is the 3 power of 1 by 7? Remainder 6. Right? 6 by 7. You can write 6 by 7. So the remainder is 6. Right? Next. 3 power of 4 by 7. Just multiply 6 into 3. Already you know 3 cube by 7 equal to 6. Right? What happens? See this 3 cube into 3. I can write in this way. Right? Already I know 3 cube by 7 is 6. 6 into 3 by 7, right? 18 by 7, 4, right? To understand, I elaborated, right? You can do mentally also, right? Next, 3 power of 5 by 7. So 4 into 3, 12 by 7. So remainder is 5. 3 power of 6 by 7. The remainder is 5 3s are 15. 15 by 7. The remainder is 1. You need to do till you get the remainder 1. That is the logic. Right? Now you know 3 power of 6 by 7 equal to 1. But we need 3 power of 28 by 7. Right? So I make this way. 3 power of 24 into 3 power of 4 by 7. Now I need the remainder for this. Right? I need the remainder for this. What is this? I know 3 power of 6 by 7 remainder is 1. So this power is divisible by 6. So this will be the remainder 1 into 3 power of 4 by 7. What is the remainder for 3 power of 4 by 7? 4. So the answer is 3 power of 28 by 7. The remainder is 4. The same thing applicable for 59 power of 28 by 7. Right? Clear? Understood? Good. Now we will see few properties. The first property is remainder of expression ax plus 1 by a whole power, ax plus 1 whole power of n by a is equal to 1. You will get the remainder for this expression always 1 for all values of n. That means, suppose if I have 85 by 7, in what way I can write this one? 7 into 12 plus 1 by 7. So the remainder is will be always 1, right? So what is the remainder for 85 by 7? First check. 7 12s are 84. 1. The remainder is 1, right? So when you can write the expression in this way, 7 into 12 plus 1 by 7, whatever you are multiplying with this number, the divisor also should be the same number. Then you will have the remainder 1. See, by applicability of the remainder theorem, how can I write this one? 7 into 12 by 7 plus 1 by 7. So here remainder is 0, right? Here the remainder is 1. So 0 plus 1, 1. Right? Understood? Now 100 by 9. So in what way I can write? 9 into 11 plus 1 by 9. So what will be the remainder? Always 1. Right? So if you have power 85 by 7, 85 power of 58 by 7, the remainder is still 1. So 100 power of 100 by 9 is still the remainder is 1. Right? Right? Now see one more example. Find the remainder when 100 power of 99 is divisible by 11. Right? See 100 by 11. How can we write 100 by 11? 11 into 9 plus 1 by 11. Right? So it is in the form of ax plus 1 by a. Right? So now 100 power of 99. So this should be power of 99. So this is n. So the remainder is 1. So for this also the remainder should be 1. Right? You can solve this problem in the normal way also. In the normal way also it is easy. No need to worry about that. Right? Good. Good. See another property. A power of n by a plus 1 leaves a remainder of a if n is odd. What is saying? If you can write in this expression, when you write this, when you can write the given number in this expression, what will be the remainder? A. If n is odd, what will be the remainder? If the remainder is 1, then n is, if n is even, when n is even, the remainder will be 1. When n is odd, the remainder will be a. For example, right? We will take one example for easy understanding. 8 power of 24 by 9. We can do these sums in normal way also. Okay. no need to worry. Right, first 8 by 9. So what will be the remainder? 8. So 8 square by 9. So 64 by 9. So the remainder is 1. Right. Now I know 8 square by 9. When I know the remainder for 8 square by 9 is 1. Right. So what I can write here? See whether n is divisible by 2 or not. See the number. See the n is divisible by 2. Right. So 24 by 2. Why we need to divide by 2? Because I got the remainder 1 at 8 square by 9. That is the reason you need to divide with 2. So how much you get remainder? What is the remainder? 0. Right. So when you get the remainder 0, what is that? Then definitely if n is divided by 2, then the remainder is 1. Understood? So 8 power of 24 by 9 is, remainder is 1. Right. Now according to the property what we have discussed, it should be in the form of a power of n by a plus 1. Right. So 8 power of 24 by 8 plus 1, right, is in this form. And see here, n is even or odd. N is even. So what is the remainder? So the remainder is 1. Right. Shall we take one more example? Right. So another example, 15 power of 45 by 60. If I do in the normal method, 15 by 16, remainder is 15. 15 square by 16, the remainder is 1. Right. So the remainder is 1. So I got the 1. I can stop it. So now what is the thing? So n should be divided by 2. It is not divisible by 2. So what? So which is the nearest number is divisible? 15 power of 44 by 16 will be the remainder 1. But what is the thing we need? Into. This should be. This is the thing we require. Right. Now I need to find the remainder for this. The remainder is 1 here. This is 15. So the remainder is 15. Right. Now according to the property, what we need to get? So 15 power of 45 by 15 plus 1. Here n is odd. So what will be the remainder? A. Right. That is A is nothing but 15. Simple. Right. Right, clear? Good. Now see the third property. Remainder of a power of n plus b power of n plus c power of n plus d power of n plus so on by a plus b plus c plus d plus so on equal to 0. Remainder of this expression is always 0 when two conditions are satisfied. 1. This a, b, c, d should be in the arithmetic progression. What is arithmetic progression? 2, 3, 4, 5, 6. What is the difference? The common difference should be same. Then we say that numbers are in the arithmetic progression. Suppose 32, 34, 36, 38. Whether these numbers are in arithmetic progression or not? Yes, these numbers are in arithmetic progression. How can you say? Because the common difference for every number is 2. Right? Same way, this also the same thing. A, B, C, D should be in the arithmetic progression and n should be the odd. Right? N should be the odd number. Then only the remainder of this expression will be 0. Right? For example, 16 cube plus 17 cube plus 18 cube plus 19 cube by divided by 70. Right? What is the remainder for this expression? Right? You need to find the remainder. Find the remainder. Right? you need to find the remainder for this expression, right? Now see whether 16, 17, 18, 19 are in arithmetic progression or not, because the common difference for these numbers is 1, right? So definitely you can say that 16, 17, 18, 19 are in arithmetic progression, right? And what is the other condition? N should be odd, right? N equal to 3, that is odd, right? What is the third thing? It should be in this form, but we have here 17. Now count these numbers. So A equal to 16 and B equal to 17 and C equal to 18 and D equal to 19. Now count it. A plus B plus C plus D. So 16 plus 17, 33. 33 plus 18, 51. 51 plus 19, 70. Right. So it is satisfied and it is in the shape of this expression. Right. So N is odd and these numbers are in AP. So the remainder is 0. Right. Understood? Good. Right. Next one. Next property. The remainder when f of x equal to a plus bx plus cx square plus dx cube plus so on is divided by x minus a is f of a. When you have this expression a plus, like what is this expression? Right. When you have 2 plus 3x plus 4x square plus 6x cube. When you have these type of expressions, when divided by x minus a, right, something x minus 2, then what will be the remainder? Remainder will be f of 2. This is f of x, right? So you need to substitute the value of 2 in the place of x, then you will get the remainder, right? Understood? Right. Now see the example. Find the remainder when f of x equal to x cube minus 7x minus 6 is divided by x minus 4. Right? Now what will be the remainder? Remainder will be f of a. Right? So remainder will be f of 4. Right? So the expression will be 4 cube minus 7 power of 4, 7 into 4 minus 6. So 4 cube 64 minus 28 minus 6. So 64 minus 34, 30. So the remainder is 30 for this expression. Right? Understood? How to use? Right.